Hey, a little while ago I made an effect that shows a rainy window, and I made it in ShaderToy though, and I figured that it could be pretty cool to use that in a video game. So I decided to revisit that effect, make it a little bit cooler, and make it in Unity so that you could potentially use it in a video game or any kind of interactive installation that you might be thinking of. So what we'll be making in this project is this shader over here. So here we have a plane with the shader on it, and yeah, it's transparent, you can look through it, but it makes the background kind of foggy, and you see like a bunch of these drops here. So pretty cool. So let's try to make this from scratch. So what I'm gonna do is I'm going to make a new material down here. So I'm gonna go create shader, and then I'm going to make an unlit shader for this one, and let's call it window, and let's have a look at that shader. So I just double click on it, and now I also have to apply that shader over here. So let's go click over here, and then we're going to go unlit, and then the new one that I just created, window. So that just creates a standard unlit shader that has only one texture on it. So so let's get to work with this. So let's go over here and let's go into the fragment shader, which is that last part over here. And let's just get rid of this, and let's just make a black screen for now. So I'm gonna go here, equals 0, and not, oh, hang on, 0. And so now I have a black screen, and now I'm going to make a grid, because there are going to be a bunch of drops, and every drop is going to be in its own grid cell, and the drop is going to stick on the window, and then it's going to slide down, and then it's going to stick in a new spot, and it's going to slide down. So let's make this grid. So for that I'm going to make a UV coordinate, and that's gonna take as an input the UV coordinate that I get from the vertex shader, and then I'm going to multiply that by a value that I'm going to expose to people working inside of the inspector. So for that I made this underscore size thing over here, and I'm gonna go over here, gonna make that, and then I'm gonna also add it inside of the properties block up here. So size, and then I have to add a label, and then I have to say what type of data it has. It's just a number, so that's float, and then let's just set it to 1 for now. And all right, so that's that. And now now that I've multiplied that by some potentially larger number, I'm going to take the fractional component of that to get repeats on my screen. So I'm going to call it GV, and I'm going to take the fractional component of my UV. And let's just visualize this so that we see what we're looking at here. So if I save that, so now I have a bunch of repeated boxes here, and I can, if I go into the settings here, I have this size parameter here that I can change to change how many boxes I get. All right, great. So now these boxes, they have their origin in the lower left corner. I don't want that, I want the origin in the middle. So I'm just gonna subtract 0.5 from that. So now the origin is in the middle of each box. And then the next thing I'm gonna do is I want to make these boxes higher than they're wide, so that when we have a drop in it, the drop can slide down properly. So for that, I'm going to make a float 2 here, call it aspect, which gives me the aspect ratio of the box. Actually, it's probably the inverse aspect ratio, because I'm going to say, okay, squeeze my box twice, or by a factor of 2 in the x direction, and in the y direction leave it the same. And now if I multiply this here by the aspect, you will see that all my boxes just got squished like that. So now the box is twice as high as it is wide. And let's just draw some outlines on these boxes so that we can easily see what we're doing. So I'm going to say if gv.x is larger than 0.48 or gv.y is larger than 0.49, then make it a nice red color. So red would be this. And yeah, so let's have a look at this. Okay, and the reason why that is because inside of each box my origin is in the middle, and the box goes from -0.5 to 0.5 over there. And this just says if we're closer to the edge, then, well, if my edge is at 0.5, then if I'm really close to the edge, to the x edge or to the y edge, then just make it a red color. So now we can just get rid of this, and we still can look at what we're working with. Okay, so now I will start drawing some drops in here. So I'm going to do float drop equals smooth step. And because we're going to use this smooth step a lot, I'm going to actually make a define for that. So I'm just going to copy that, and I'm going to go over here, and over here I'm going to say define s a comma b comma t smooth step a comma b comma t. And that just makes it that I don't have to type smooth step each time. I could just type this. What this define does is kind of like a smart way of doing a search and replace. So if you define something, then what you're telling Unity, okay, before you compile the shader, search and replace. Every time it says smooth step with this pattern after it, replace it the other way around. Every time it says S down here in the code with this pattern after it, it will replace it with smooth step with the same pattern. So it's just a fancy search and replace, but it just makes it a lot faster to write stuff. Because now I can just go S over here. And if you're going to use that 20 times, you're going to save some time. So let's draw a drop. And I'm going to take the length of GV. So the length of my GV coordinate is just the distance from the pixel that we're in to the center of the box that the pixel is in. So let's see what that looks like. Plus equals drop. Okay, and now you can see we have a little drop in the middle of each box. But the drop is stretched, and that is because it's inside of the box that's also stretched. So in order to undo that, we have to undo this multiplication by aspect by dividing it by aspect over here. So now we have a perfect round little drop. Okay, so now the next thing is we want to make that drop move. And so, yeah, so we're trying to make it that the drop sticks to the window, and then it slides down, and then it sticks to a new point, and then it slides down. So for that, this is going to get a little bit more complicated. So let me just cut this out and call this drop pause. And then I'm going to go over here, and I'm going to call this drop pause. Okay, so that didn't change anything. And now in order to move that drop, what I'm going to have to do is over here, I'm going to subtract a position from my GV. And I'm going to subtract x comma y, and then I have to make my x and y. So let's just set them both to 0. Y equals 0. So that shouldn't change anything because I'm just subtracting 0 and 0. But now I can move my drop around. So now I can, for instance, to move it to the right, I can just do that. What I'm going to do is I'm going to make it that the drop goes up and down inside of its own box. So for that, I could just do the sign of t, of time. So anytime you animate something, means it's a function of time. So that means that we have to involve this time dot y. So Unity gives me underscore time. That's just part of Unity, which is the number of seconds that have elapsed since you started pressing play on your scene. So and then this is a structure that has x, y, z, and w, and they're just the times that go at different speeds. And the time dot y is the time value that increases by 1 for each second. So now we have t. So now I don't have to write underscore time each time. And so now if I stick that into a sign, then my sign is going to go from 1 to -1. But my box goes only from +0.5 to -0.5. So it will go out of the box if I do this. If you see here now it's gone and it just crosses through the box. So I have to multiply this by some smaller value in order to have it visible all the time. So like 0.5, let's say. So now it goes from the top to the bottom, or from the bottom to the top. But I want to have it that it goes down fast and then it goes up slow. And for that, I came up with this. So if I go to Desmos, so right now we just have the sine of x, which goes up and down like that. And I just came up with this. So this is just me playing around on Desmos until I get something. Times 0.5. So that's the formula that I'm going to use. And so now this one goes up fast and down slow. So I can just put a minus in front of that to turn it around. So let's use that. So here I'm going to do the sine of t plus the sine of t plus the sine of t times 0.5. And then I'm going to make it negative because I want it to go down fast and up slow. So now it's going up. And then boom, it goes down fast. Okay, now the next thing I'm going to do is I'm going to make it that the entire grid moves down at the same speed that this dot moves up. Okay, to counteract the movement, because obviously we never want drops going up on the window. So for that, I'm going to go over here. And I'm going to say uv.y plus equals time times some value to tweak it so it goes exactly the same speed. Okay, so now I have boxes that go down and my drop stays more or less in the same spot. And then like if it still moves a little bit, you know, as long as it still moves down, and I guess that's good, but you could tweak that. All right, so now we have that. Now the next thing is we want to make it that this drop leaves a little trail of smaller drops when it falls down. And actually before I do that, let's make it that we can scrub time so that it's kind of easier to test while we're building this. So instead of this over here, I'm just going to add something to this here. So if I do that, then it will just null out the time, and then I'm going to do plus underscore t. And that's a time value that I'm going to expose to the outside so that we can scrub the time. So I'm going to go over here and I'm going to add that t time, and then that should be okay. So let's see what that looks like. Okay, so now it's stopped because I just multiplied my time here by 0, and now I have a time value over here that I can move around to kind of scrub time myself, which is easier for when we're building things. All right, so so the trail of drops. So let's clean this up a little bit, and let's go over here and let's copy this entire thing. And then here, instead of drop pause, I will call it trail pause. Trail pause, and then here I will call this trail. And trail pause. Okay. And now let's make it that we have one drop that is stuck right in the middle. So for that, let me just set that to 0 here, so so that my trail drops don't move up and down. So now if I add this, col plus equals trail, and also let me make them a little bit smaller, those trail drops. So let's say 3 and 1. Let's have a look. Okay, so now we have one little drop in the middle that we want to turn into a string of little droplets. And so for that, what I can do is over here, So right now my trail pause goes from 0.5 at the top of the box to minus 0.5 at the bottom of the box. So if I do this, trailPause.y equals trailPause.y times 8, let's say. So now my trailPause.y will go from +4 to -4. And now I'm going to take the fractional component of that. So frac. So that will just slice the space into a bunch of different boxes, the same way that we slice the space into the boxes that you see over here. Let's have a look at what that looks like. So save that. So now we have a bunch of drops, but they're all very squeezed, and that is because we're multiplying by 8 over here. Well, that means that outside of the frac we have to divide by 8 in order to get rid of that distortion. So do that, and now we have a bunch of drops, but they're all cut off halfway, and that is because when you first do a frac, the origin is going to be at the edge of the box. So similar to how over here we had to subtract 0.5, well, over here we also have to subtract 0.5. So but before we do the divide by 8 here, so minus 0.5. Okay, so now we have a string of little drops. But there's one problem with this, which is that when I scrub time, you see that those drops, like they move with the red boxes, and obviously when it leaves the trail drops, we want those trail drops to stick to the window to the same spot. Well, for that I could just use the same offset that I use over here. We could just use that inside of the Y over here to cancel out that movement. So now if I go over here and I move this, you see that those drops, they stay in the same place. All right, now the next thing is to make sure that there are no drops underneath the main drop, right? Because we want to make it that the main drop kind of deposits those little drops. So we have to we have to mask that out, and how we do that is by multiplying these little drops by a number that is 0 for every pixel underneath the main drop, and it's 1 for every pixel above the main drop. So then if you multiply something by 0, it's going to cancel it out. If you multiply it by 1, it's going to not do anything to it. So for that, I'm going to go over here, and I'm going to multiply my trail by some function that is 0 or 1, depending. And for that, I'm going to use a smooth step. And we can realize that the drop pause over here is going to be negative for every pixel underneath of the main drop, and it's going to be positive for every pixel above the main drop. So we can use that. So if I go over here and I say droppPause.y, and then let's say minus 0.05, 0.05. So what this function will do now is everywhere drop pause is smaller than minus 0.05, it's going to return 0. Everywhere it's above 0.05, it's going to return 1, and anywhere in between it's going to do some smooth interpolation between the two. So let's see what that looks like. And I'm going to have to scrub my time so you can see actually. Yeah, so now you can see that that there are no drops underneath the big drop. Okay, so the big drops kind of deposit the little drops. Okay, the next thing I want to do is I want to trail off these drops so that towards the top of the box they get less and less. And for that I could do exactly the same thing. So trail times equals, and now we have to make a function that is 0 at the top of the box and it is 1 where the drop is. Okay, and so for that I'm going to use the gv.y, because my gv.y goes from 0.5 to minus 0.5. And so I know that the top is 0.5, and now I need to figure out where the drop is. Well, the drop is at height of y. So if I do this, then this just gives me a gradient from 0 all the way to 1, and then it stays 1 after the drop. So let's see. Okay, so now we have now we have a nice faded drop. All right. So on the next thing, oh yeah, so we can do, so this drop right now is totally round. I mean, it's a very minor thing, but I wanted to do it anyways. So the drop is very round right now, but if it's stuck on the window, then you would think that it would be sagging down a little bit. So for that, what I can do over here is I can draw this drop at a different height for every X, for every column, right? So if I did this, for instance, plus equals GV dot X, then I would expect it to skew. Because my GV.X is negative over here, so meaning that it would draw the drop lower on this side, and then as you go towards the right, for every column it draws it higher and higher and higher and higher. That's why this does that. And so you could take the absolute, for instance, and then you can kind of see how you could shape stuff like this. So now it goes in positive directions, or like in both directions, it moves the drop higher. But obviously I don't want a kink in it like this, so what I'm going to do is I'm just going to make a parabola out of this. So I can just do GV.X times GV.X, and then it will make a nice round change. So, and then I'm going to make the sag the other way around. So it's kind of minor, but it shows you like kind of the power of what you can do. So this is the difference between a round drop like this or a saggy drop like that. Okay. Anyways, minor stuff. The next thing I'm going to do is I'm going to yeah, I want to make it that this drop like doesn't go straight down, but sometimes it has a little wiggle. As if there is, I don't know, some grease on the window or something like that. And for that, we can just use this X over here, right? Because if I do that, then I can move it left and right. And actually, before we get too far in that, like just notice that sag that we just did on the drop, you need to take the X into account for the sag as well, because otherwise it's just going to distort more and more as you get away from the center. So for the sag to properly work, I would have to go minus X over here and minus X over here. And then the sag will just move with the X. So I could make this a sine wave, and then you would have a drop that goes down like that. But I want it a little bit fancier, so what I came up with was something like this. So let me just... so if I take a sine wave and I, let's say, do that to some power, to the third power, fourth power, fifth power, sixth power. So what I did is do it times the sixth power and then multiply that whole thing times 3x. I mean, there's different ways you could do this, but this is what I came up with. Well, and you got to imagine this vertically. So imagine the drop goes down and then it has a little wiggle, and then it goes down and has a little wiggle the other way. So let's implement that. So I'm going to go over here. I'm going to go the sine of, and then we have to think about what we're going to throw into this sine, because if I just throw this uv.y into it, then my wiggle is going to move downwards with all the boxes, which we don't want. We want that wiggle to stick to the window at the same spot. So for that, I'm going to use i.uv.y, and let's just take that out over here and make a variable for that. And then also I will multiply it so that I have a few more wiggles. Otherwise, it doesn't change enough. So I'm going to do 3 times w times the 6th power of just sine of w. Okay, and now with the x, it's the same as with the y over here. I have to multiply it by some smaller number so that it doesn't go outside of the box. So let's see what that looks like. Okay, so now we have a bunch of very wiggly drops. But you can see that, okay, it does a little wiggle, then it goes straight, then it does a little wiggle, then it goes straight, and so on and so forth. Okay, maybe this is too much, so we could, well, yeah, let me well, no, like I guess it's okay. So this this maybe looks a little bit better. So it's straight, and then it does a little wiggle, and then it's straight again. All right. So now the next thing I want to do is, obviously these drops shouldn't all go all at the same time in some sort of synchronized swimming competition. So what we have to do is we want to offset them for each box in a different offset. And the first thing I need for that is I need a different number for each box. So I need, first of all, I need an ID for each box so that we know which box we're in. So for that, I'm going to go over here. I'm going to say float2 ID equals the floor of UV. And let's just visualize that real quick. So let me go down here. Let me null out all the color so everything's black. And then col.rg equals ID. And let's look at that. Okay, let me just multiply this by some smaller number. Okay, that should also go up and down. Let me see here why that is not the case. Okay, let me just set, okay. So like now you can see that every box here has a different value. And now we can use that value and turn that value into a random value that we use to offset the timing. So let's make a function that can take two numbers as an input, so, and it returns a pseudo-random value as an output. So I'm going to go over here, float2p, and let me just write it down. So frac p times float2, and then so I'm just gonna take this number and multiply it, or take this vector 2 and multiply it by some other vector 2 that is large, so that now like the position is very large, and now we take the fractional component of that, so now this p is somewhere between 0 and 1, and now I'm going to do p plus equals the dot product of p and p plus some number. And this is just this is just some mathematical screwing around, or some mathematical transformation that is so complex that we can't see the pattern afterwards. Even though there is a pattern, we can't see it, and therefore it looks random to us. There are different ways to make random numbers. It's maybe out of the scope of this video right now, so I'm just going to write it out. Y. Okay, so let's just test this. Let me see how good my random numbers are. So col plus equals n to 1, and then I'm just gonna throw the UV coordinate, let's say, into it. So I expect to see some white snow. Okay, and I see some snow. And so it's always good to test this to see if it looks random enough, because sometimes it doesn't. And also another thing before I forget is that this t value over here, that would just increase and get bigger and bigger and bigger. And because this is a floating point value, floating points have their precision goes down. As the number goes up, the precision goes down. And like you might get some issues with this. Let me see here if I could show that. So if I take the UV instead of I.UV, let me see. Okay, so now that changes because my UV changes. Let me take the ID actually. So the ID. Okay, so now I have a bunch of random, pseudo-random values. But if this number so right now it looks like it works. Okay, it works pretty good. I don't really see a pattern, so that's good. But if this number got really, really large, so let's say you've left this running for like 5 hours, then I might have a number that is that large. Okay, maybe that's not large enough yet. Okay, so now you can see if you get too large, then my random function or my pseudo-random function doesn't look terribly random anymore. See, like at some point you start seeing patterns. And to combat that, what you want to do is you want to make sure that you wrap this number around so that it never can get too big. So I'm going to go over here, and then I'm going to go, so that's for the pseudo random number. But there are other issues as well. If you have a number that's too large, that's stored in a float, it's not going to be precise anymore, and then what you'll get is, let's say, stuff starts stuttering. Like it doesn't move smoothly anymore if it doesn't look smooth anymore, and that's usually because your numbers are too big. So let me just say, okay, just reset every 2 hours. So every roughly 2 hours, well, 2 hours would be that. It just resets so that we never get numbers that are large enough to kind of screw up everything. All right, so now we have a random number for each box. So let me just zoom back in, and now we could use that random number to offset our to offset the drops. So let me just get back to the drops. So now what I can do over here is I can say float n. For noise is n21, and I'm going to throw the ID into it. And so now this gives me a pseudo random number between 0 and 1. And now let's offset the time for this, for the falling of the drops. And for that, actually, okay, so I'm using my time over here. So if I go over here and say t plus equals n, so now what that would do is that the time between different boxes can change by at most 1. Okay, so you could see that like now it looks already a lot more random, but they still kind of go in waves, and that is because we're throwing this number that can only at most differ by 1. We're throwing that number into a sign over here and over here. And the phase of a sign is longer than 1. The phase of a sign is 2 pi. So you have to multiply this at least by 2 pi to get the full amount of randomness that you can get. So now the timing is completely random. So that's for the timing for the up and down. Let's also make it that these drops can go left and right. So for that, I could just go over here and just get rid of the wiggle for 1 second, and we could say so my n varies between 0 and 1. So what I could do is I could add n minus 0.5 to that. Okay, so now this value can go from minus 0.5 to 0.5, and then obviously I still have to multiply that by 0.45. Is that correct? No, I have to. So now this goes from minus 0.5 to 0.5, and now we can have a look at that without the wiggle. And now we see that like they're left and right, but sometimes over here you see that one is cut off, and that is because this is still too large now. Yeah, anyways, it's too large. So let's just multiply by a smaller number, and now that is better. And now in order to get the wiggle back, let's go over here and say plus equals, but I can't just add this wiggle now because then if we have a wiggle for a drop that didn't start in the middle of the box, it will wiggle outside of the box, like over here. So what we have to do is we have to make it that the wiggle gets proportionally smaller as we get closer to the edge of the box. So for that, I'm going to use this x value here. So right now this x value goes from minus 0.4 to 0.4, right? There's a random number from minus 0.4 to 0.4. And we just want to throw that into a function that returns 0 when it's either at minus 0.4 or it's at 0.4. And as it gets closer to the center, it gets larger, closer to 1. And so for that, I could just do something like this. I could say the absolute value of x, 0.4 minus the absolute value of x. So if I do that, then if I throw 0.4 into here, then I get 0.4 minus 0.4, which is 0. If I put minus 0.4 in here, then I get the absolute value of minus 0.4, which is 0.4, and then the whole thing goes to 0 again. So if I multiply this now I will have it that it will cancel out the wiggle for any drops that are close to the edge. So these drops don't wiggle, but this drop did wiggle because it was closer to the center. Okay. Oh yeah, okay, so the next thing would be to have, I wanted that these drops, that they cut I wanted that there is fog on the window, and when there's a drop, it kind of cuts a trail through the fog. And for that, the first thing to realize is that what I need for that is similar to what I have over here for the string of droplets. So let me just do this. Float fog trail equals this, and then fog trail times equals that, and now if I multiply my trail by the fog trail, times equals fog trail. Now that didn't do anything. That's functionally the same as what I had before. But now I have access to this fog trail over here. So let me just look at what the fog trail looks like. Plus equals fog trail. And let me just multiply by some smaller numbers so that we can still see stuff. And so yeah, let me just stop this for a second so we can have a good look at it. So times 0. Okay, so those fog trail, like what I have right now, it's already I gotta find one. It's already pretty good in that it fades towards the top of the box, and it's not shown underneath the box, but obviously it needs to be cut on the left and on the right as well. So for that I could just do a fog trail times equals smooth step, and then for that I can use drop pause dot x, and if I did this 0.05, 0.05, so now I would expect only the left side to be cut off. Okay, so now it's only the left side cut off, and now, like, what? Obviously this is not what I want, but it will show you maybe a little bit better. So now if I do the absolute, now I would expect only something in the middle that is not showing, and then we're just gonna turn that around. So let's say 0.5 and 0.4, let's say. Okay, so now we have only a trail in the middle. All right. The next thing is, yeah. So now we have this, and now what we want to do is, so let me just get rid of the borders here. And so now what I want to do is I want to make, use this texture as an offset texture to read pixels from the background texture. So let me just get the background texture back. So call equals text 2D, and then I'm going to say main text and i.uv. Okay, so that's my main texture. And so if I use that black and white drop texture to offset, I could use that to offset this UV coordinate, and let's see what that does. So so let me just make something here called float to offset equals, let's say, drop plus trail. So that's only the drop plus the trail drops. And if I add that here, offset, then you will see that it already does something. Okay, it does some sort of offset here. It's just not the most beautiful offset. And so let's work on that a little bit. The first thing I want to do is I want to make this tweakable. So I'm gonna add a variable called _distortion, and I'm gonna multiply my offset by that. And let me just go over here and add it over there, and then also add it over here. And I'm gonna say distortion, and if I make that a number that is between 0 and 1, then I could just multiply that by that number, and that will change my distortion. And actually, let's just go also negative so that we can see what that distortion looks like in both directions. And then my default would be 1. Okay, so now if I make this a little bit larger, so now I could tweak this already a little bit. But again, like this offset is not correct, so we have to work on the offset. And the reason why this looks right now is because my offset is kind of the same. It's only in one direction, and yeah, it's just not very good. So let's go over here. Let's make a proper offset for this. So what we would want is that if I have a pixel over here, that the that the offset, like the offset points in the direction away from the center of the drop, and for that I could just use drop pause. So if I do drop times drop pause, actually let's just look at drop pause by itself for 1 second. So I'm just going to do call times equals 0, call.rg plus equals drop pause. Okay, so like these are the offsets, and they are with respect to where the drop is. So that's already pretty good. So let's use that. Let me just look at the drop by itself, at the main drop by itself. Okay, and now it's hard to see stuff, so let's increase the distortion. Okay, so now we have drops that look much better. Yeah. So, and here you want it actually negative because so that it flips the sky and the ground around. If you had the distortion positive, then it would be more like a reflective surface. So if you had a droplet of, I don't know, mercury or something, then you would want it positive. But we're gonna have a negative. Okay, so let's do the same trick for the trail. So plus trail times trail pause. Okay, and now we have the offset for the trail as well. Yeah. All right, so that's already looking pretty watery. So let me just turn this back on here. All right, and then increase the size. All right, so this was part 1 of this tutorial. In part 2, we're going to add the fog, and we're going to also make it that it's actually transparent, because right now we have this trick just with the texture, which is already pretty cool, but not terribly useful for a video game, I imagine. So please like, subscribe, click the little bell icon so you don't miss when part 2 comes out, which is going to be very soon. And anyways, thank you for watching, and I'll see you next time.